Hi, my name is Joakim Bruslund Haurum, and I will be presenting the paper Multitask Classification of Sewer Pipe Defects and Properties using a Cross-Task Graph Neural Network Decoder. This is joint work with Meysam Madadi, Sergio Escalera, and Moeslund. The sewage infrastructure is one of the most important infrastructures in modern society. In order to ensure that the sewer pipes are functional, the pipes are inspected by licensed professionals. For over 30 years, researchers have investigated how to optimize this inspection process. While the defect classification task has been given a lot of attention, classifying sewer pipe properties such as pipe materials and shape has not been given any attention, even though they are necessary in order to determine the pipe's deterioration level. As an example, look at this image from within a sewer pipe. Not only are there 3 different defects within this image, there is also the water level, which in this case is 0. Then there are the pipe shape, which is circular, and then there is the pipe material, which is concrete. Instead of having separate networks inferring each of these tasks, we investigate using multitask learning, specifically multitask classification. The main portion of the multitask learning literature within computer vision is focused on dense per pixel classification tasks. For these tasks, there are 2 main methods of how to structure your model. First, there are the encoder-focused models, where the encoder is shared and you then have n disjointed task heads. Secondly, you have these decoder-focused models, where again you have the encoder, but now in the decoder heads, knowledge is shared between the different tasks. However, for the multitask classification subdomain, the literature is much more sparse, and the datasets considered are either repurposed multi-level classification datasets or a collection of disjointed datasets with no cross-task sharing. We therefore present the Cross-Task Graph Neural Network Decoder, a method specifically designed for multitask classification datasets where there are concurrent and related classification tasks. The first step of a Graph Neural Network Decoder is to generate task-specific features, which are then used to generate unique class embeddings for each of the classes within that task. The class features are then refined using a graph neural network, which encode the relationships between classes and across different tasks. Lastly, the node embeddings returned by the graph neural networks are each projected down to a scalar, and the final activation function is applied. An essential part of our proposed method is the graph neural network refining class embeddings based on the relationship between classes. These relationships can be inferred dynamically using attention, or they can be provided beforehand. When we explicitly provide the class relationship information, we do this using an adjacency matrix. We compute the adjacency matrix by first calculating the conditional probability between all classes across all tasks. We then threshold the matrix in order to remove spurious edges, and then constrain the edge weights to sum to 1 in order to avoid the oversmoothing problem. We evaluate our proposed method on the sewer mode dataset, which contains 4 concurrent and related classification tasks, and 1.3 million images from sewers annotated by professional licensed inspectors from Denmark. We compare against 3 different methods: the single-task network, a standard hard-shared encoder network, and a state-of-the-art soft-shared encoder network. We have observed that when using our proposed method, we get state-of-the-art performance on a majority of the classification tasks, while introducing 50 times fewer parameters compared to a previous state-of-the-art soft-shared encoder network. We also observe that using multitask classification approaches leads to an improved performance on the sewer pipe material and shape classification tasks. For more information about our method and results, please go to our project webpage, where you also find links to code and pre-trained models.